Hello! I have a mustache. How wonderful is that? Um, I don't know how you feel about mustaches. I don't know how I feel about mustaches, but I felt like having one, so let's do this. Let me know. Send me a message in the chat or something like that. And tell me how wonderful my mustache is and if you want me to keep it around, or tell me you hate it and you want it to go immediately. Either way, today we are going to get back and finish up the project that we've been working on. So I have a dev command to get our server started. And let's see, I don't think that ever worked. So we can close that. Some stuff I was looking on, don't worry about it. And yeah, what are we working on? We were looking at progressively enhancing forms, and there's two sides to this project. Most of it is front end work. A little bit of it is back end work. So let's just kind of do a recap of where we ended up. Why is that? Okay, that's right. We have this form. Let's look at our HTML. And in our form, we have an action, which is the URL to send the request to once it's submitted. We have a method of post, which means it's going to send the data as a post request in the request body. And then we have several inputs. We have text input with an aria described by, which doesn't exist. I think we did that before for testing. Maybe we should keep that there. Let's do name description and expand that to say how you call yourself. So we have an input with an aria described by attribute to the description. We have an input with a type of email, which is also required. We have an input with a type of number and a minimum of 5. We have a radio input inside of a field set, and all of these are going to share the same name because it's for the same sort of input. All of these are marked as required because you have to fill something out. And yeah, their type of radio, that's the most significant thing there. We also have a field set for pizza toppings with checkboxes. And the checkboxes are going to have that in order to make your pizza, I guess, you have to put pineapple and you also have to put bacon. So let's say that one, let's say that one is required as well. And then we have a select, which is of type multiple. We can select multiple ones. That one is also required. And then we've got our submit button below. And finally, we've got some client-side JavaScript. So if I go to my form right now, we can see that we've added the how do you call yourself. Some of the things that we did with this form is we've used JavaScript on the client side. We'll start down here, I guess. Essentially, when this JavaScript loads, it's going to look for all of the forms on the page, and it's going to set the no validate attribute to true. And the reason why we do that is because we want to handle the validation with JavaScript, which means we don't want the native HTML validation to run when we hit submit. And what that looks like is, let me toggle JavaScript off. So the default form validation is when I hit submit, it's going to find the first invalid input. In this case, this name is required, and it's going to focus on that input and say, hey, please fill out this field, right? Our implementation, on the other hand, we want to disable that feature from running because we want to actually trigger the submit event on the form. So that way, when the submit event runs, we can check the form validity method to see if the form is valid or invalid. In the case that it's invalid, we can loop through all of the inputs inside of the form, and we can set a data attribute which we're using this just to check whether it's allowed to run the validation logic. And then we're going to call the validate input function on that input. In addition to looping over all of the inputs, we're going to search for the first invalid input. So only the first one using query selector. We're going to avoid invalid field sets because that is a thing. And we're going to call focus on the first invalid input. Finally, we're going to prevent the default behavior and stop this internal event, this submit event function from running. That's in the case that we have invalid inputs. In the case that we have a valid form, we want to use JavaScript to submit the form. And on successful submission, we're going to, or I guess on a bad response, if it's not successful, we're going to alert, hey, there was an error with the submission. On successful submission, we're going to alert something about the data that came back, and we're going to reset the form to whatever the data was when it was submitted. So here we've got two client-side functions that we've not looked at. So let's look at the validate one first. Validate input takes an input element, and then it looks for the first input of this with the same name. And the reason why we do that is because there's a special scenario where on radio inputs, we want to show the validation error message only under the first error, or only under the first input, not under all, in our case, 3 of them, or however many there are. So we don't want to show the same error multiple times for the same set of inputs in the case of radios. Right, so then we take that logic, we store a little ID variable, and we say, hey, if it's a radio input and the current input is not the first of its type, we're going to set the ID to the first input in the group with the same name. Otherwise, we're going to grab the ID from either the current input's ID if it exists. If the current input ID does not exist, we're going to randomly generate an ID, and then we're going to go ahead and assign that ID to the input so that next time it comes around, we're still working with the same randomly generated ID. Next, we're going to build out, we're going to start working with the errors and the ARIA described by attribute. So I think this actually makes sense. No, I guess we need that there. So we grab the existing ARIA described by attributes if there are any. If there are some, then we split it so that we end up with an array of each different ARIA described by attribute, because it can be space separated values. If there is not already some defined, then we just start with an empty array. And then we also go ahead and filter out any ARIA described by values that are match our error's ID here, which is based on the ID that we got before. Next, we capture the validity state API from the input. We set the ARIA invalid attribute based on whether the input is valid or invalid. And then we remove this error, this element with the ID of error's ID if it exists. That's what this question mark here does. If up until here is truthy, then we know it exists, which means we can call the remove method. Next, we dive into the validation logic. So if the input is not valid, we're going to build an errors array. We're going to create the container or the element for the errors messages. We're going to set the ID for that, and we're going to give it a class of errors, which we don't actually use later, but you probably want to have some sort of styling for it. Next, we do a little bit of logic. This is not complete, but this is an example of checking if the value is missing. That's corresponds to the required attribute. This pattern mismatch corresponds to the type attribute. Range overflow and underflow correspond to max and min, and yada yada yada. Pattern mismatch, I actually got that wrong. Pattern mismatches if we pass in a pattern or like a regular expression pattern. Type mismatches if we got the type wrong. So if the type is email, for example, and we put in just a regular string, this is going to say, hey, you've got the wrong type here. Okay, so finally, with our errors, we take our error ID object, or our error ID string, and we push it to the descriptors array. And remember, the descriptors were all of the ARIA described by values. And then we're going to say that the text content for the error message container is going to be the list of existing errors joined together and space separated. Here, one more little bit of logic. If we have a radio input again, we need to handle that a little bit different because we only want to place this errors container after the first radio input with the same name. Otherwise, we want to put this errors container below or after the current input that we're looking at. This will make a little more sense when I show the example again. And last but not least, if the descriptors.length, meaning we actually do have some ARIA described by attributes set, we want to put that back on to our input. So if it previously had ARIA described by attribute, we want to make sure it remains there. If we've added our errors ID or error container connection, we want to also include that. And that's it for the input validation. We also do, well, I guess we missed a little bit of logic here that on load, we also do add event listeners for the blur and input event on each input. And that's connected to validate on event. Validate on event detects whether it's a blur event or not, and basically does some logic to say, is this the first time, or has the input been focused and then blurred? And if so, go ahead and run the validation logic. If it hasn't been focused yet, we don't necessarily want to run the validation logic because we don't want the bad user experience of telling someone, hey, you entered something wrong as they're typing. We want to wait until they've had a chance to fill it out or at least tried to submit the form. We'll look at that in a moment as well. Okay, and the last bit of logic here on the client side is this JavaScript form, submit form, which takes a submit event. When we have that JavaScript submit form function running, what we do is we grab the form DOM node off of the event target. We grab the URL based on the form action. If the form action is not defined, we'll fall back to the window location.href, which is the current browser URL. From those, we will build a URL object, which we'll use later. Something else that we capture from the form is the form data. So form data object or constructor is going to take all of the inputs and the values and basically create an object of name and value based on the inputs. Very handy. We also do the same same thing where we pass that form data object into a URL search params constructor. And the URL search params constructor is kind of similar to form data, except I guess the biggest difference is one is an object that you might send. Well, I don't know a good way to describe the difference, so just disregard that. But we do need them both, and we'll see that in a moment. Next, we create an object which is going to be passed into our fetch method later on, or our fetch request later on. So this is going to be the options, which is the second parameter to a fetch request. And then we do a little bit of logic to check and see if it's a GET request or if it's a POST request. HTML forms can only have one of those two methods, GET or POST, which means if it's not one, it's going to be the other. The default value is GET. So if you don't define any, it's going to fall back to a GET request. In the case of a GET request, we want to send that data the same way that a browser sends it. So we're using JavaScript here, and we're using fetch here, but we want to imitate the same way that the browser is going to do it by default, which is when you submit a form with a GET request, that all of the data, such as like name Austin, is going to be appended to the URL of the action. So where the form is being submitted, it's going to be appended as a query string parameter, which is worth looking up if you're not familiar with that. We can do that by setting this search params object to the URLs object's search property. So we have a URL object. We set the search property equal to the search params that we constructed up here. And that's all we need to do. The browser will handle actually building out the URL differently, which is great. If we're not working with a GET request, we can assume that we're working with a POST request. Which I guess it could be the case that the form method was set to something that doesn't exist. So I guess we probably should actually switch this to, if it's a POST request, we're going to do this, right? Otherwise, we will assume that since nothing else would be technically valid, if it's not a POST request, we'll just assume it's a GET request and do that logic here. So in the event of a POST request, we want to send the data in the body of the request, again, to imitate the same thing that the native browser behavior does. One other thing we need to account for before we just set the body of the request is whether the form's enc type has been set to multi-part form data. That is an encoding type that's that modifies the content type of the request. Also information that's probably worth looking up if none of this makes sense. But the reason why it's relevant is because when you set the body of a fetch request to a form data object, it's automatically going to change the content type of that request, of the request headers, the content type headers, to multi-part form data, which could have implications if your backend doesn't support multi-part form data. So we only really want to do that if the form's enc type is also set to multi-part form data. That way we maintain the parity between native browser behavior and what we're doing with JavaScript. If multi-part form data is not set as the enc type, then we can go ahead and send the search parameters object that we created, that we constructed above, as the form body. The reason we do that is because sending that as the form body maintains the default browser behavior of the request headers content type being XWWW URL encoded form, something like that. I don't remember off the top of my head, but it doesn't really matter. It's the default browser content type for submitting a form. Once we've completed all of that, I hope you're still with me. Only at the end do we prevent the default behavior. We explicitly put this at the bottom of this function because if anything fails during calling this function, we don't want that event to have been prevented. Meaning, if this is called first and then there's an error after it, the event behavior has already been prevented, meaning the form will not submit, but we also won't get down to the fetch request. So by putting this at the end, we know that if there's an error here, JavaScript will stop execution. The browser will fall back to submitting the form because the default behavior has not been prevented, and it will submit the form. In the event that there's not an error, we prevent the default behavior and we return the fetch request with our URL and our constructed options. Hope that makes sense. I'm going to try and do the same explanation on the function call podcast, which is going to be a little bit more difficult because we're not going to have this code to look through, but we'll see. Hopefully we can do it. Okay, and that's all the client-side JavaScript. The cool thing about this, let's see, we're looking at 136 lines of code, including comment blocks, including white space, not minified. That's not a lot of code. And the cool thing is that this works for every single input, every single form. We don't have to modify anything. We don't have to do any funny state management or custom stuff. I mean, we can, but it's not a lot of code to get the benefit that we're going to see here. So make sure my JavaScript is running. Cool. First, we'll look at the validation logic that we were looking at. If I just come through and try and hit submit without filling anything out, I'm going to get a bunch of error messages, right? This one is going to say, hey, this value is required. It's going to say the same for all of these where the value is required. On this radio input, it's only going to say the value is required under the first one. Oops, I accidentally clicked that. But that also mimics the default browser behavior. And then for these radio options, these are required. This select box, this is required. Cool. In the event that I don't just try to submit right away and I tab through this, I might just skip after that. And when I trigger that blur event, I will see that error message. And maybe I'll come back and say, my bad, I meant to fill that out. And now as I satisfy that validation requirement, that error message goes away. Same with the email. However, as I type in, I have because it's more than just required, it also has to be an email. I see that this value is not of the expected type, which is an email. The number, I can trigger that and say, well, I'm going to give this a number of 2, and it says the value is too small. It should be 5. So let's say 25. That's certainly greater than 5. Favorite operating system, we'll say it's Linux. And as we blur that, that one may also want a change event because that was probably, we want to see that error message go away when I click that input, which input events I think are a little bit different on radio inputs. Nonetheless, we can continue. Pizza toppings, yeah, pizza, pineapple, bacon sounds good. And we'll click 1. So that was kind of our validation logic. We saw that go through. Something that we're not seeing as able-bodied sighted users is that this validation logic is also being updated here. Let's see, let's look at this. See if I can get that big enough for you to see. Right, so here we can see that, let's refresh. We can see that our input looks the same as we have in the HTML. This is just what I wrote. But as I blur and trigger that validation logic, I can see that some things have changed. One, my aria described by attribute has changed. I still have the name description there, but I'm also getting this name errors reference, which is referencing this ID or this div with an ID of name errors, which again wasn't there to begin with, but as we trigger the validation, it gets appended to the DOM. So those are connected. That is a pretty good accessibility feature that not only does this input have a valid label, but it also has a valid description, both in the name description and the name errors. They're both associated with this input. We can also tell some assistive technology that this input is in fact invalid. And yeah, that's pretty cool if you ask me. I definitely like getting those accessibility features in there. And if I type something, we can see that those get updated. Our error message is gone. The aria described by goes back to its previous state. It's still dirty, which is what triggers our validation. And then aria invalid is now false. So that one's good to go. Okay, so that's it for the front end stuff. The other recap for the back end work that we did, we're not going to be able to see here. So let's go to our server side backend code. The main part we're going to focus on is this request or this API endpoint that's going to /API. aptly named. We can get rid of this request body console log. And the only really interesting thing that's going on here is this first block. What we're doing is we're saying, hey, if this request comes in and the headers, the sec fetch mode headers equals navigate, then we're going to redirect this request with the 303 status code back to the request headers refer value, which is wherever the request came from. So if the request fetch mode is navigate, go back to where you came from. And the reason we do this is because this is how we can detect native HTML requests, HTTP requests. That might be through a form submission or a page navigation. A form submission to send a GET or a POST request. A page navigation will send a GET request. I can test that by disabling JavaScript. I can see I've got my form here. I can see that my form is, the action is going to /API, meaning when I submit this form, I expect the browser to navigate to /API, sending my data in the body of the request. So let's send that. Let's send that. Let's send the number 6. That. Doot. Everything is valid. When I submit, I can see that my form cleared. And the reason why, actually, I'm going to do that one more time, just so you can see. This network request here, we're going to see it pop in really quick, and then the browser is going to essentially redirect back to where it came from. So submit, API request went out. Cool. Came back with the redirect instructions. The browser read the redirect instructions and redirected back to localhost 3000. Hopefully that's clear. And that's a really good way, in my opinion, way that I've been playing with providing API support for progressive enhanced forms, meaning if you want to send a request with JavaScript, go for it. We're going to respond to that request with JSON. But in the event that your JavaScript fails, the user has ad blocking on that prevents JavaScript from running, or bad connection, or you just want to use HTML to talk to my API, I can detect whether that a request came in through HTML. I can run my logic regardless. So this actually would probably make more sense like up here. So we do some logic that for a post request, let's say we want to add a new blog post. We want to like do the logic as if it's a valid request. But then instead of responding with JSON, we're going to just redirect back to where they came from, because an HTML request doesn't know what to do with JSON anyway, so it's not useful. Okay, the last thing I'm going to show here is probably I would want a little bit of a different API design where, let's say, I don't know, maybe you're dealing with like IDs or whatever. But in the event of my API, I'm going to say, if you want to create a post, you're going to send a post request to API, or I want create, right? I want to send a post request to API/create. That's going to increment my counter, whatever. And then that's going to return the counter. If you want to if you just want to get the current information, we're going to do this. So this is like, if we're looking at it from the create, read, update, delete perspective, this is going to be the read, right? This is going to be create. And then if you want to update, HTTP verbs the appropriate HTTP verbs would include patch or put, depending on how you want to run your updates. However, because HTML forms do not support patch and put, they only support post, I'm going to actually have this be a post request. And this is going to be like API slash, what am I doing? Update. Let's say create, read, update. So this imitates the patch or put. And instead of incrementing, we're going to say counter equals request body counter. Sure. In the event of an HTML form submission, we're going to do that. Otherwise, we're going to return the current count. And the last route that I want to work on is delete, right? So create, read, update, delete. In the event of a delete, I'm going to set counter to 0, and that's going to be it. Keep in mind, the focus here, don't worry about what the counter is doing. This is imitating some database action that might actually create, read, and update, delete posts. This route might actually make more sense if this was like some ID, or like an ID there, right? An ID there. Create doesn't need an ID, and this read might be like some ID like that, right? Cool. What I want to focus on here is the URL structure. Because HTML forms only support get and post methods, we might have to build our APIs differently if we want to support submissions through HTML forms. This same idea of progressive enhancement. So because we have to work within the constraints of using only get methods or post methods, we can satisfy that requirement by modifying how we structure our URLs for our API endpoints. So if you want to read something, if you want to read a blog post or a user profile or something like that, you do like, a GET request, and you get the ID of the user blog post or whatever. If you want to create a new one, let's say blog post, you might say in a post request to API slash, what I say, blog post, blog, right? This might be like that. Reading an individual blog post might be, let's see, we might have something more like this where we have, I think I'm going to clean this up a bit, and I'm actually going to pull these down so they're in order. So create a blog post, you post to API slash blog. Read all of the collections of all of the blog posts, it's a GET request to API slash blog. Read an individual blog post, it's get API slash blog slash ID. Update an individual blog post is going to be a post request to API slash blog slash the ID of the target blog post, and then slash update. Delete a blog post is going to be a post request to API slash blog slash the ID of the blog post slash delete. So we're only ever dealing with get and post requests, but we're using the structure of the API to determine what actions we're going to be performing. You may agree or disagree with this. I think it's cool because this means that just HTML can start making API requests. So that's it for this recap. I hope that was helpful. I hope that was interesting. If you have questions, feel free to reach out. Otherwise, let me know what you'd be interested in watching or having me build or something like that. If you don't tell me something, I'm going to come up with something that I find interesting. So yeah, I think that's it for today. We might just call it short. Is there anything else I want to do? I don't think so. So yeah, that's going to be it. We're going to call it short. And I want to say thank you. I really appreciate everyone that's been coming on the show and chatting and just watching. So if you like the show, please be sure to subscribe and like it and share it. trying to get other people involved. So I hope you keep coming back. Yeah, have a great evening or morning, and I'll see you next time.